Good day, everyone. Today, we will learn about addition and subtraction of dissimilar rational algebraic expressions. In adding or subtracting dissimilar rational algebraic expressions, we have to change the rational algebraic expressions into similar rational algebraic expressions using the least common denominator or the LCD and proceed as in adding or subtracting similar rational algebraic expressions. Before we add or subtract rational algebraic expressions, let us first find the LCD of the following expressions. So first we have 3x over 4y and 3y over 6x. So to find the LCD, we have to factor each denominator. So the denominators are 4y and 6x. So the factors of 4y are 2 times 2 times y, and the factors of 6x are 3 times 2 times x. So we have to align common factors. Next is to multiply the factors. But we have to first bring down all the factors. We have there 3. Then, since 2 is common in both the denominators, so we will take that as one factor. And then another 2. And then x. And then y. So therefore, the LCD is 3 times 2 times 2 times x times y. So multiplying these factors, 3 times 2 is 6 times 2 is 12. So the LCD is 12xy. Next, let's find the LCD of 5 over 8m squared n to the 4th power and 2 over 6m cubed n. So again, let's factor each denominator. So the factors of 8m squared n to the 4th power are 2 times 2 times 2 times m times m times n times n times n times n. And the factors of 6m cubed n are 3 times 2 times m times m times m times n. Then, let's bring down all the factors. So we have there 3, then 2. Since it's common in both the denominators, so we will take that as 1. Then another 2, another 2. So again, so m is common in both the denominators, so that is taken as 1. Another m is common in the two denominators, so that is taken as 1. Then we have another m. So n is common in both the denominators, so that will be taken as 1. Then bring down all the 3 n's. Okay, so therefore the LCD is 3 times 2 times 2 times 2 times m times m times m times n times n times n times n. So multiplying these factors, we have 24m cubed n to the 4th power. Next, let's find the LCD of x over x minus 2 and x minus 1 all over x plus 3. So observe that both the denominators are not factorable and there is no common factor between the two denominators. Therefore, the LCD is quantity x minus 2 times quantity x plus 3. Next, number 4. Let's find the LCD of 4x over x squared minus 25 and 5 over x minus 5. So we can factor x squared minus 25. So since it's a difference of two squares, so the factors are sum and difference of two binomials. So simply get the square root of x squared and square root of 25. So that will be quantity x plus 5 times the quantity x minus 5. And the other factor, which is x minus 5, is not factorable. So we will just align it in its common factor, which is also x minus 5. And then, let's bring down the factors. We have x plus 5, then x minus 5. So therefore, the LCD is quantity x plus 5 times the quantity x minus 5. Let us now add or subtract rational algebraic expressions. First example, 5 over 8m squared n to the 4th power plus 2 over 6m cubed n. Since these expressions have different denominators, so we have to first find the LCD. So the LCD is 24m cubed n to the fourth power. Then we have to write the equivalent expression of each rational expression so that the denominator of each expression will be 24m cubed n to the fourth power. So we have to then find the numerators of each expression. So to find the numerator of each expression, we have to divide the LCD by the denominator and multiply the quotient by the numerator of the original expression. So let's first find the numerator of the first expression. So again, divide the LCD, which is 24m cubed n to the fourth power, by the denominator of the first expression, which is 8m squared n to the fourth power. So dividing, that will be dividing 24 by 8, that is 3. So this will be 1. Dividing m cubed by m squared. So this will be m, and m squared will be 1. And then dividing n to the fourth power by n to the fourth power, so that will be 1. So simplifying, that will be 3m. So the quotient will be multiplied by the numerator of the first expression, which is 5. So 3m times 5 is 15m. Next, let's find the numerator of the second expression. So again, we have to divide the LCD, which is 24m cubed n to the fourth power, by the denominator of the second expression, which is 6m cubed n. So dividing 24 by 6, so this will be 4. Then m cubed divided by m cubed is 1. Then n to the fourth power divided by n, so that is n cubed. So simplifying, that will be 4n cubed. Then again, the quotient will be multiplied by the numerator of the second expression, which is 2. So 4n cubed times 2 is 8n cubed. So now we can add the numerators. So that will be 15m plus 8n cubed over, so we have to just keep the LCD, which is 24m cubed n to the fourth power. Since we cannot add 15m and 8n cubed, and it is not also factorable, therefore the sum is 15m plus 8n cubed all over 24m cubed n to the fourth power. Next example, x over x minus 2 plus x minus 1 all over x plus 3. Again, since these expressions have different denominators, so we have to first find the LCD. So the LCD is quantity x minus 2 times quantity x plus 3. Okay, then we can now write the equivalent expressions of each rational expression, making the denominator equal to quantity x minus 2 times quantity x plus 3. Okay, now we have to find the numerators of each expressions. So to find the numerator, we have to divide the LCD by the denominator, then multiply it by the numerator. So let's first find the numerator of the first expression. So that will be, okay, so LCD divided by the denominator, which is x minus 2. So we can cancel out common factor, which is x minus 2. So that will be 1. So the remaining factor is x plus 3. So we have to multiply this by the numerator of the first expression, which is x. So multiplying x times x, that is x squared. Then 3 times x is 3x. So the numerator of the first expression is x squared plus 3x. Next, let's find the numerator of the second expression. So again, we have to divide the LCD by the denominator of the second expression, which is x plus 3. So we can cancel out common factor, which is x plus 3. So that will be 1. So the remaining factor is x minus 2, which is multiplied by the numerator of the second expression, which is x minus 1. So let's multiply using the FOIL method. So multiplying the first term by the first term, so that will be x times x is x squared. Then the outer terms, which are x and negative 1, that will be negative x. Then multiplying the inner terms, which are negative 2 and x, that will be negative 2x. Then the last terms, negative 2 times negative 1 is positive 2. So then we can combine similar terms, which are negative x and negative 2x. So adding negative x and negative 2x, that will be negative 3x. Therefore, the numerator of the second expression is x squared minus 3x plus 2. Now we can add the numerators. So that will be x squared plus 3x plus x squared minus 3x all over, plus 2. So all over the LCD. So we can keep the LCD, which is quantity x minus 2 times quantity x plus 3. So in the numerator, we can add similar terms. So adding 3x and negative 3x, that will be equal to 0 since they have different signs. And then x squared plus x squared is 2x squared, and so that will be plus 2. So that will be 2x squared plus 2 all over. So we just simplify the LCD, which is x minus 2 times the quantity x plus 3. So we have to multiply. So the product is x squared plus x minus 6. So therefore, the sum is 2x squared plus 2 all over x squared plus x minus 6. Another example. Okay, this time we have to subtract 3x over 4y by 3y over 6x. Again, these expressions have different denominators, so we have to first find the LCD. So the LCD is 12xy. Then now we can write the equivalent expressions of each rational expression, making the denominator equal to 12xy. Okay, now let's find the numerators of each expression. So by dividing the LCD by the denominator and multiply it by the numerator. So let's first find the numerator of the first expression. So we divide the LCD 12xy by the denominator of the first expression, which is 4y. So that will be, then dividing y. Okay, so simplifying, so that will be 3x. Then this quotient will be multiplied by the numerator of the first expression, which is 3x. So 3x times 3x is 9x squared. Okay, so that is now the numerator of the first expression. Then now let's find the numerator of the second expression. Again, we divide the LCD 12xy by the denominator of the second expression, which is 6x. So dividing, that will be 2. This is 1. And dividing x by x, so that is 1. So simplifying the remaining factors, that will be 2y. Then 2y will be multiplied by the numerator of the second expression, which is 3y. So 2y times 3y is 6y squared. So that will be the numerator of the second expression. Now we can subtract the numerators. So that will be 9x squared minus 6y squared. And then we just copy the LCD, which is 12xy. So simplifying the numerator, we can factor this out. So there is a common factor, which is 3. Then we divide the common factor to each term. So that will be 3 quantity 3x squared minus 2y squared all over 12xy. Then we can cancel out 3. So that will be, okay, 12 divided by 3 is 4. So simplifying, that is, okay, 3x squared minus 2y squared over 4xy. So the sum is 3x squared minus 2y squared over 4xy. Last example, subtract 4x over x squared minus 25 by 5 over x minus 5. Observe that x squared minus 25 is factorable. So we have to first express x squared minus 25 in factored form before finding the LCD. So the factors of x squared minus 25 is a sum and difference of two binomials. So that will be, okay, quantity x plus 5 times quantity x minus 5. Now let's find the LCD. So the LCD is quantity x plus 5 times the quantity x minus 5. So let us now write the equivalent expressions of each rational expression. So by the denominator, which is the LCD, quantity x plus 5 times quantity x minus 5. So again, let's divide the LCD by the denominator of the first expression, then multiply it by the numerator to get the numerator of the first expression. So that will be, dividing common factors. So simplifying, so that is equal to 1. So multiply by the numerator of the first expression, which is 4x. So 1 times 4x is 4x. Then, let's find the numerator of the second expression. Again, divide the LCD by the denominator of the second expression, which is x minus 5. So we can cancel out common factors. So therefore, the remaining factor is x plus 5. Then we multiply this by the numerator of the second expression, which is 5. So 5 times x is 5x, then 5 times 5 is 25. So the numerator of the second expression is 5x plus 25. Now we can subtract the numerators. So that will be 4x minus quantity 5x plus 25. Since we are subtracting more than one term, so we have to put the terms inside a parenthesis because multiplying a negative times positive 5x, that will be negative 5x. Then multiplying negative times positive 25, that will be negative 25. Okay, so over the LCD, which is quantity x plus 5 times quantity x minus 5. So let us now simplify, combining similar terms. 4x minus 5x is negative x, so that will be minus 25 over, so we can now simplify x plus 5 times x minus 5. So let's multiply that. So the result will be x squared minus 25. So the sum is negative x minus 25 all over x squared minus 25. Let us now summarize what we have learned. To add or subtract rational algebraic expressions with unlike denominators, first, find the least common denominator, or the LCD, and then write the equivalent expressions of each rational expression. Then add or subtract the numerators and keep the LCD. And last, simplify the result if possible.